algorithms are meant for determining the routing packets in a node. These routing algorithms are classified into two types. One is the static routing, another one is dynamic routing. So here we will discuss about the distance vector routing algorithm. This is one of the example of one of the algorithm of dynamic routing. So it is an intra-domain routing protocol. So intra-domain means routing inside the autonomous system, means whatever the network is there, within that network only the routing will take place. Means each and every node will update the data periodically. So the neighboring node, it will update the data to the neighboring nodes. So what is this distance vector routing algorithm? It is also known as Bellman-Ford algorithm. So this distance vector routing algorithm is also called as Bellman-Ford algorithm. So it will be introduced in the year of 1970s, like that. 1960s to 1970, this Bellman-Ford algorithm was introduced. Each node shares its route to its neighbors and does not broadcast. That means by using this distance vector routing algorithm, each and every node will share its information to its neighboring nodes only, but not broadcasting. That means but not share the information to all the nodes. Just information is shared to its neighboring nodes. For example, A is connected to B and B is connected to C and D is another node, for example. So here A will share information to D and B only, but not to C. So like that, B will share information to its neighboring nodes, that is A and C, but not to D. So like that, each node shares its route to its neighbors and does not broadcast to the all nodes. Whenever any node receives the routing information, immediately it updates its own routing table and inform to its neighbors. So here in distance vector routing algorithm, for means each and every router will maintain a routing table. So routing table is consisting the distance vectors of the neighboring nodes, means whatever the neighboring nodes are there and what are the weights from that node to the neighboring node, that will be maintained in the routing table. So in distance vector routing algorithm, each and every router maintains the routing table. Whenever any node, means any node receives information from any router, then immediately it will update the routing table and inform to its neighboring nodes also, because the neighboring nodes also update the information. So working principle. So what is the working principle of distance vector routing algorithm? So step 1, here each router prepares its routing table by their local knowledge. Each router knows about all the routers present in the network. That means each and every node or each and every router prepares to maintain the routing table. So initially they will set the values in the routing table and they have the knowledge about all the weights of the all the nodes in the network. So here it will maintains all the routers present in the network, means it will known about all the routers present in the network and distance to its neighboring routers. That means how many routers are there in that network, that will be known. And the second thing is the distance between the neighboring nodes. So each and every router will known about the distance from that node to the neighboring nodes. That is also mentioned. So this is the first step we will take in the distance vector routing algorithm. So in the second step, each router exchanges its distance vector with its neighboring routers. So in the second step, what we'll do? First thing is each router, means each and every router exchanges its information. So initially the routing table is updated. Next, each and every router will update its data. For example, any router is failed, then it need to update now. So that's why each and every router updates the information periodically. Each router prepares a new routing table using the distance vectors it has obtained from its neighbors. So initially it is updated with a values in the routing table. Once the neighboring nodes gave the information, means updated some information, then immediately all the nodes are connecting nodes, means neighboring nodes will update the routing table. Another routing table is maintained. In that routing table, the updated data, means whatever the information given by the neighboring node, that information is updated. So periodically these things will be happen. In the next step, the same things, means whatever the previous cases, means the neighboring nodes informed to the remaining nodes about the updated information. So the same things will be repeated up to n minus 2 times if there are n routers in the network. So for example, if the network consisting of n different routers, means n different routers, then the same steps are repeated for n minus 2 times. So because each router is connected to at least 2 devices, so that's why n minus 2 times the same steps are repeated. After this, routing tables converge or become stable. So, after the completion of n minus 2 times, means each and every time the tables are updated. So, after completing that one, the tables are converged or becomes stable. That means once each and every router's data is updated in the routing table, then we converge it. Converge means each and every router maintains the information about the different routers, means for example a to b and b to c. By using this distance vector routing algorithm, we will maintain the distance between the routers. Once we know about the routers are connected, and the neighboring nodes maintaining the data about the neighboring nodes, then by using this distance vector routing algorithm, we will maintain the shortest distance between the nodes. And finally, the source node is transmitting the data to the destination node in a easy way. So here we will consider an important point. So what is that mean? From time to time, mean that is periodically, each node sends its own distance vector estimate to the neighbors. So for example, one node is existed. So that node's data will be informed to the neighboring nodes. And after some time, it will identify a shorter path, means before it is updated some data. So after updating data, it will find another route that will be reached to that node in a shorter path, means shorter distance. Then again it will update the data to the particular neighboring nodes. So like this, periodically the data will be updated in the routing table until the stable state occurs. So stable state means that is the final state. So after that stable state, it will never be changed. When a node X receives new distance vector estimate from any neighbor V, it saves V's distance vector and it updates its own distance vector using the Bellman-Ford equation. So what it means, if you have A, B, C, some D is there. So for example, consider these 4 routers. So here, if you consider the distances between these routers, so from A to B it is 2, from A to C it is 7, from B to C it is 1, from B to D it is 3, and from C to D it is 8. So if you consider like this, so this is a subnet. It consisting of 4 different routers. So every time each and every router maintains the routing table. So what the routing table consists? So routing table consists the distance from one router to the another router. So here it maintains the distance. So for example, consider the routing table of A. So if you consider the routing table of A, so from A, what is the destination nodes? So destination nodes are B, C and D. So initial step, we will consider the routing table. We will maintain the routing table. So what the routing table will consist? So the routing table consists the distance from that node to the another node. So here initially from that node to itself, we will consider it as 0. Means initially from that means A to A, the distance is 0. And from A to another node, if any distance is there, we need to update that distance. So from A to D, the distance is 2. So we need to update the distance value as 2. And from A to C, a direct connection is there. So the distance is 7. So we need to update the value as 7. And from A to D, is there any direct connection? No, there is no direct link between the nodes, that is A and D. So here in this case, we will put the initial value as infinite, because there is no direct link between the node A and node D. So we don't know the distance. So for finding the distance between that node to the remaining node, so because in distance vector routing algorithm, the each and every node knows about the information about all the other nodes in that particular network. So that's why we need to maintain the distance. We need to maintain the distance for each and every node. Initially it is infinite. So later we will update the data, because periodically each and every router will update the data. So see here A to C it is 7. Once B's data is updated, if router B updates it neighboring nodes. So what are the neighboring nodes of B? The neighboring nodes of B is A and C. So by using means through this path B, we will travel to C also. So there is a link from A to C, not only direct link, there is another path, that is A to B and B to C. So if you consider the direct link A to C, the distance is 7. So if you consider the other path, that is A to B, B to C, then what is the weight here? 2 plus 1, that is 3. So when compared with the direct link, the other path is having the less distance. So we need to update the value as 7 is crossed with 3. Because if B is updated with its neighboring nodes, then immediately the routing table will be updated. So updated with a shortest distance value. So how this shortest distance value is obtained by using the formula that is called as Bellman-Ford equation. So Bellman-Ford equation, by using the Bellman-Ford equation, we will find the values. So here, so d of xy is equal to min value of c of xy plus dv of y. So for each node y, so by using this equation, we will find the values. So minimum value, we need to find the minimum value. So what is this c of xy and what is this d of vy? So we'll see. So c of xy is nothing but the cost of direct link from x to v. So first we need to consider the direct link value. So next thing is we need to consider the distance vector. So estimate of least cost from x to y. So we need to find the other paths and we will add the values and we will find the value. That is called as distance vector. So we need to use the other paths and we need to calculate the value. That value is called as distance vector. So now from the direct link cost and the distance vector, we need to find the minimum value. So that complete equation is called as distance vector equation, and that equation is given by Bellman-Ford. So what is dv of y? Node x maintains its neighbor's distance vector. So dv of y is nothing but node x maintains its neighbor's distance vector. So in the last example we see, so a to c is the direct link, that is called c of xy. So from a to b, b to c, another data is there. So that distance vector is nothing but dv of y. Now from c of xv to dv of y, we need to find the minimum value. So we need to find the minimum value. So here minimum c of xy plus d of vy. That's it only, not this one. So for each node, y belongs to n. So n means that network. So whatever the network is there, in that network, y is one of the router. Then by using this formula, we will find the shortest path. Each node v periodically updates dv to its neighbors. So each and every time, the vectors will update the distance vector value to the routing value, to the particular neighboring router. So by whenever it is updated, then only we need to update the information in the routing table. So like that, we will update the routing information for each and every node. Mean from a to b distance, a to c distance, and from A to D distance. So like that, each and every router maintains the routing table. Until the stable state, we will we will update the routing table only. So here we will consider one example for distance vector routing algorithms. So here if you observe, the network consisting of 5 different routers. So the different routers are A, B, C, D and E, and it will be represented in the form of graph. So in distance vector routing algorithms, all the routers are connected in the form of graph. So here the weights are mentioned on the edges. So edges means the link between the routers. So A, B. So in between A and B, there is a edge is there. That edge is nothing but link. So above to that edge, the weights are displayed. So like this. So each and every node means every link is weighted edge only. So this is a weighted directed graph because the directions are mentioned here and the weights are also mentioned here. So what is this weight here? It could be the distance or cost or delay. So it may be anything. It may be the distance between the rotors, or it may be the cost, or it may be the delay time. So anything we will consider it as a weight. So now this is the graphical representation. So for example, this is a network consisting of 5 routers. Then how the distance vector routing algorithm will work. So what is the initial step? In the initial step, we need to maintain the cost values. So initially the cost of node to itself is set to 0, and node to node any value is there, we need to update that direct link value. And if any node to any other node is infinite, if there is no direct connection. So for example, if there is no direct connection between the nodes are there, then we need to initialize the value with infinite. So let us see the table here. So we need to write down in a matrix format. So all the rotors are existed here. So if you observe, what is the first one? We need to set the value of itself, node to itself, as 0. So here A to A, that is 0, B to B, that is 0, C to C, that is 0, D to D, that is 0, and E to E, that is also 0. That is the first step. And the next step is, if any distance is there, any weight is there directly, then we need to update. So from A to B, there is a direct link. And what is the weight here? 7. And A to C, there is no direct link. If there is no direct link, then we need to set the value as infinite. So A to C is infinite. So like that, A to D, there is no direct link. So we will put infinite here. And from A to E, the direct link is there, that is 1. So like this, for B, C, D and E also we need to update the value. So each and every router will maintain the routing table. So here the distances are written like this. Now every node means periodically each and every node will update its neighboring routers data. So for example, D sends vector to E. For example, if you consider, because A to B, A to E, we have the direct links are there. But C and D are not directly connected to A. Now, D will update its information by sending the vector to E. So, how it will send vector to E? I am 2 from C, like this. So, I am 2 distance from C and 0 from D and 2 from E. So, what is the distance between C to D? C to D is 2, D to D is 0, and from 2 to E is 2. Now, D is 2 distance away from 2 plus 2, that is less than infinite. So 2 plus 2 means less than the infinite value. And if you consider the value, so the best path to C is 4. So update the value here. So D is updating here. What is the D values mean? This one, D to A, it is infinite. D to B, it is infinite because there is no direct connection. D to C is 2, and D to D is 0, and D to E is 2. So 2, 0, 2. Now, first we need to update the value of C here, because E to C, there is no direct link is there. So through the device D, the distance from E to C is updated as 4, because initially it is infinite. Now by using the router D, the distance from E to C is updated as 4 here. Like this, we will update all the infinite values and all the other distance values also. So we will check each and every case. So let us see another one. Now here B sends vector to A. For example, the router B. So the router B sends a vector to A. So here what is the main values here? So B to A, it is 7. B to B, it is 0, and B to C, it is 1. So B to C is direct link, that is 1. B to D, there is no direct link, so we will put as infinite value, and from B to E, it is 8. Now here B will introduce, means B will update its information and sends a vector to A. So here what will happen? Through the B, means through the router B, A will connect to C. So by using the router B, it will connect to C, because initially A to B, A to E is, the data will be available because direct links are available. From C and D are located in an infinite distance. So now from router A to routers C and routers D are connected. So how it will be connected mean, to D via E is connected, and for C via B is connected. That is the initial steps. Means after initial step, we will take the steps like this. Now through B, what is the distance from A to C? 7 plus 1, that is 8. Initially it is infinite. Now compare the infinite value with 8. So which is the least one? 8 is the least one. So we need to update the routing table with 8. So here C value is updated like this. Next. So now the distance from A to D and A to C, everything is updated. Now see, so here E sends a vector to A. So E will update the value. So in the initial step, E's data is updated, but through E, now A is connected to D. So how it will connected to D? So see, already we know E, D and C are connected in the first step. Next step, B, C is connected to A, that is known. Now E will send a vector to A. So E's data is sending to the A. E is directly connected to B, and E is directly connected to D, and E is connected to A. So through D it is connected to C. So now when E data is sent to A, now through E it will calculate the values to all the other nodes. So see, so from A to A, from A to E, what is the value here? 1. So this is updated. Next, A to B, it is 7. Next, A to E, E to D. So A to E and E to D. What is the value here? 1 plus 2. So that value is 3 here. So we know in the first step, D is updating it information that D is directly connected to C and with a distance of 2. Now, if you consider the path like this, A to E and E to D and D to C, then what is the cost here? 1 plus 2 plus 2. So that is 5. But in the previous case, through B, the cost value is 8. So now it is compared. It is compared with the other path distance. So that is 5 only. So 8 and 5 are compared. So in 8 and 5, the 5 is the minimum value. So that's why the value of C and the value of 3 both will be updated. So like this, we will find the other rotor values also. Now A to E is connected, E to D is connected, D to C is connected, and the other connections also we know, A to B, B to C. Now, in other direction, A to E, E to D, and D to C, it is 5. And from C to B, if it is connected, what is the value here? So, A to E, E to D, D to C, C to B. So if you calculate like this, the value is 6. But the direct link consisting of 7. So now what is the minimum value? Even though the direct link is there, but through the other path, the distance is very less. So that is the shortest distance. So by using the direct link, so without using this direct link, the distance from A to B is updated like this. So see here A to B distance is updated like this. So now from each and every device, each and every router, it will calculate the distances to all the other devices. So A to A is 0, A to B is 6, A to C is 5, A to D is 3, A to E is 1. So like this is the routing table, updated routing table for A. In the similar fashion, we need to update the routing table information of B, routing table information of C, and D and E. That means each and every router maintains its own routing tables. So whenever the neighboring node updates its information periodically, then immediately the routing table will be updated with a new value. So every time it will find the shortest path only. So by using that shortest distance, the source node will transmit the packet to the destination nodes. So this is about the distance vector routing algorithm. So coming to advantages, distance vector routing protocol is easy to implement in small networks only. So if it is a bigger networks, so large networks are there, then there is a clumsy will occur because every time it need to update the data. So if more number of routers are there in that network, then it will be very clumsy. So to update the data is also very crucial. So that's why these distance vector routing algorithms are very easy to implement in a smaller networks only. Debugging is very easy in distance vector routing. So debugging means if any errors are occurred, then that will be debugged very easily in the distance vector routing algorithm because it is a small networks. So in that small network, if anywhere errors will occur, so we need to debug it. So that will be possible in distance vector routing algorithms. This protocol has very limited redundancy in a small network. So due to the small network, redundancy is also very limited one. So these are the advantages of distance vector routing algorithms. So advantages are there. Along with that, we have some disadvantages also there. So what are the disadvantages with distance vector routing algorithm are? Here a broken link between the routers should be updated to every other router in the network immediately. So for example, A, B, and C. For example, consider three routers only. So A to B, B to C, and A to C is direct link is there. So for example, the router C is failed. Then what will happen? This link will be failed and this link also failed. For example, another router is connected through this one. So what will happen? So A to B, B to D is connection is there, and C. For example, this router is failed, then automatically the links will be broken here. So two links are broken. Then what is the network here we considered? Only A to B and from B to D. So like this, a broken link between the routers should be updated to every other router in the network immediately. So if any network is broken, because we will use the shortest path, so not only using the direct links, if any other path is existed with a shorter distance, then we will consider that path only. So if in that path, if any router is failed, then what will happen? The complete network will be collapsed. So to avoid that, if any broken link is there, then immediately the routers will update the information. So the distance vector routing takes a considerable time for the updation. So it will take a periodical time. So a considerable time is taken to update the data. This problem is also known as count to infinity problem. So this broken link problem is also called as count to infinite problem. So this is one of the drawback with distance vector routing algorithm. Another one is convergence time. So this convergence time is also one of the drawback with this distance vector routing algorithm. So what is this convergence time mean? The time taken to all the state of a set of routers that have the same topological information about the internetwork in which they are operated. Means every router, means we have n number of routers are there in the network. So each and every router maintains the routing table. So convergence time means whatever the routers are there in that network, all the routers will maintain the same routing table. So same distances, that is called as stable time or convergence time. So that is the one of the drawback, because the time required by every router in a network to produce an accurate routing table. So to produce the accurate routing table, we will maintain the convergence time. So that is also one of the drawback. In the large and complex networks, this time is excessive. So in a small networks, there is no problem for convergence time. Convergence time means the stable time for all the routers. So if it is a larger network, then the time is definitely excessive one. Means more time is considered to update the data. So that's why this is the one of the drawback in larger networks. Next one is every change in the routing table is propagated to other neighboring routers periodically, which create traffic on the network. So every time periodically we need to update the data. So if any routers are failed sometimes, so any loss of data will occur. So to avoid all those cases, periodically the data will be the routing table, mean the data will be updated to the neighboring nodes. So every time periodical means continuously it is updating the data. So that is also one of the disadvantage with distance vector routing algorithm. So this is about distance vector routing algorithm. So in the next we'll see what is link state algorithm. So the problems with distance vector routing algorithm will be solved by using the distance vector link state routing algorithm.